Good morning, guys. Again, just in continuation with the last lecture, we had been discussing reactions of alcohols with carbonyls, where I had discussed that aldehydes, when they are reacting with one equivalent of alcohol, then hemiacetal is formed. When the hemiacetal further reacts with the alcohol, or we can say aldehyde is reacting with excess amount of alcohol, then acetal is formed. Similarly, when ketone is reacting with an alcohol, then hemiketal is formed. But when ketone reacts with excess amount of alcohol, we will say ketal is formed. Now, certain facts about this reaction, which are very important as far as this reaction is concerned. The first point being that all the reactions are reversible. So we can say acetal formation the position of equilibrium, that is whether the reaction will go in the forward direction or in the backward direction, is influenced by the relative proportion, that is the amount of ROH and H2O used. If ROH is in excess, the reaction will go in the forward direction. If the concentration of water increases, then it will go in the backward direction. Point number B, acetals and ketals are stable towards bases, or we can say nucleophiles. Therefore, they can be used as protecting groups for carbonyls. It is easier to form cyclic acetals or cyclic ketals using dihydric alcohols than using simple ROH, because in the former, that is the reaction of a carbonyl with a dihydric alcohol, the entropy value is positive. Okay. Point number D. Thiols being more nucleophilic, then alcohols react faster with carbonyls. So these are four vital points that one should be keeping in mind while dealing with such reactions. Okay, but let us take some practice problems. Now, instead of going with the mechanism by which it is formed, I'm going to show you something which is much more easier. So let me first discuss the mechanism, and then I will show you the technique that I'm going to use. So the mechanism by which this reaction occurs is as shown below. So you have, say, a aldehyde. Since you are using dry HCl, so the H plus is coming from the dry HCl that you are using. This will be protonating the lone pair present on oxygen, via which oxygen now gains a positive charge, which is not stable over oxygen. Consequently, a nucleophilic attack from an alcohol will take place at the carbon of the carbonyl, eventually forming a species like this, which will lose a proton, and the molecule formed is now called hemiacetal. Okay. Now, in presence of excess amount of alcohol, further protonation of the OH of a hemiacetal will take place. Which will now lose water in the rate determining step. This is now resonance stabilized. Okay. Undergoing further nucleophilic attack from another molecule of alcohol, and the molecule that will be formed is going to lose again a proton, and finally we will get the acetal. Now see, doing this very long mechanism in an exam will be a wastage of time. Okay, so for that I'm teaching you something which will help you to not only crack the problem but also save some time for you. Okay, let's see. I have given you, say, I'm taking any type of acetaldehyde, okay? Example 1. And then I have said you try to react this with R prime OH, okay, in presence of, and I've given you one equivalent only. And obviously here we have dry HCl, okay? What you do is you convert this acetaldehyde to a hydrate. So think like it is reacting with water, and you convert this to a hydrate. of acetaldehyde. Okay, so basically it's converting to a diol, gem diol. Now you try to think that we have to take out water. How do we take out water? Just see, make a box like this. Okay, and that gives you a product. No need to do that long mechanism that you were doing previously. Now, if I had involved two molecules of alcohol, say something like this. I forgot to put a prime on that. So now I have said dry HCl. What you do is again you repeat the same step. Convert this to a gem diol. As simple as that. And now you try to take out ROH. Okay, it's not ROH, try to take out water. So you place both the ROH next to the OH. Okay, and you try to take out two molecules of water. Just like that. Okay. Now that means your answer will be something like this. And that is your acetal. Let's keep trying. Okay. Suppose now I give you a molecule like this. Okay, and I have said you are reacting with ethane diol. Okay, I've given you dry HCl. So what you do is you convert this to a gem diol. Okay, your H is something like this. Again you try to take out the water. So now you will get a compound like this. Now if this is say CH3 and this is H, CH3 and this is H, CH3 and this is H, so this is your cyclic acetal. Okay, let's do a few more examples. Okay, say question number 4. I have now given you something like that. Okay, and I have said treat this with dry HCl. What will you do? Same thing, convert these to a geminal diol. Place the OH in such a way that you can take out water. Now you're trying to take out water. Okay, so how you do? Something like that. Again you take out water, something like that. Okay, so what will be your answer? Something like this, that you have a O getting connected to this carbon, you have a O which gets connected to this carbon. So that is your answer. If I give you, say, a molecule like this, so this is acetophenone, I'm using MeOH, dry HCl. So what will be your answer? Let's say I'm giving you excess. Okay, excess means two equivalents. You have to think. You make this OH, OH, Me, Me. Again, take out water. That's it. Okay. Let's do another one. Same thing. OH, OH. Okay. Again, take out water. Obviously, two molecules of water. And you will be getting. So this is a cyclic ketone. Okay, mind it. This is only a ketone, not cyclic. This is also a cyclic ketone. Okay. Number 7. Suppose I give you something like that. So this is like a straight chain. We are using only one particular alcohol, and the compound is a ketone. So obviously, one alcohol and a ketone will give you hemiketone. So reagent is again your dry HCl. Arrange the ring in such a way that you can bring this OH and the OH from other section together. So suppose, so this is, let's number it. Okay, 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. Okay, again take out water. And your 3, 4, 5. So numbering helps you to keep the ring count proper. Okay, so you will be getting now a OH which is connected to a O, and this total ring number will be now 6 membered. Okay, so 1, 2, 3, 4, 5. This is your 6th. So technically this is your cyclic hemiketone. Okay. Now, most of the books will be discussing the formation of acetals and ketones, but there are certain questions in which we are asked the starting material. Okay, so how to find starting material? Starting material for acetals, ketones, hemiacetals, hemiketals. Okay. So this is something that is going to be unique that you will find in my lecture. Not only I will teach you formation of compounds, but also how to find out starting materials of compounds, which are also some things that are asked in competitive exams. Okay. Now let's consider a very simple one. Okay. Initially, I have given you, say, this one, A, and I am asking you, how will you know what is the starting material of this compound? Okay. Please understand. What do we need to do? Find out the carbon which is joined to two oxygen. So this is your carbon, which I have circled out. Disconnect the bond between the carbon and the oxygen. So you're doing basically a heterolytic cleavage. Okay. Give this kind of an arrow, which is indicating that you're disconnecting the molecule. Put negative charge on oxygen and positive charge on the carbon. So this particular carbon is going to have two positive charge. Negative charge will be shared by this oxygens. Where you have put positive charge, just make a double bond O. Where you have put negative charge on oxygen, just to neutralize this, add an H. And that is how you get the starting compounds. Let's do another one. Suppose I give you something like this. Again, find out the carbon which is joined to two oxygen. Disconnect the bonds. Once you have disconnected the bonds, over the carbon you place positive charge. Over the oxygens you place negative charge. As I have mentioned, make a double bond O where you have positive charge, and for the oxygen, to neutralize the oxygen, just add a proton. So that is going to be your starting material. Let's go for a few ones that are a little tougher. Now, if the first question that I ask you, is this a acetal or a ketal, what will you say? Okay, this is the carbon that is joined to both oxygen. It is joined to one more carbon over here. What is the other atom? That is hydrogen. So obviously this is a cyclic acetal. That is the first thing that you have to assign when you get these kind of problems, whether this is acetal or a ketal. Again, this is the carbon joined to two oxygen. Disconnect these bonds, so you get a minus. Here you will have plus. Here you have minus. Just follow what I had said. You have C double bond O, there's one H, and here you have now one OH, something like this. This is your starting material. Okay, let's give another try. Suppose I give you something like this. This is the carbon joined to two oxygen. Okay, now this is joined to one more carbon here, which is your Amine, another carbon here, which is your Amine. So this is a cyclic ketone. Okay, if there was a hydrogen over here, then it would have said cyclic acetal. Okay, so this is a cyclic ketone. Now again, disconnect where? Over here. What to do next? This becomes your O minus, that becomes your O minus, this is your Me plus plus, that becomes your OH, double bond O, Me. So see, this is how you can deal with this kind of problems and easily solve them without going for the mechanisms. Okay, next topic is a reaction of amines with carbonyl. Point A, primary amines react with C double bond O to form C double bond N. These are called imines. Point B, secondary amines, which are R2NH, reacts with C double bond O to form enamines, which are basically these kind of molecules. Okay, so let's take the general example or scheme. So if I have given you, say, an acetaldehyde reacting with R, something like that. Okay, some aldehyde. Okay, so obviously again think of taking out water. So just taking out water like this and try to make a double bond. Kindly understand that both the geometrical isomers will be formed, that is E and Z over here. Suppose you have taken a ketone like this and you have reacted with this, or let's make it general, Then also take out water and think that both the GIs will be formed, that is E and Z. Okay, so these are basically condensation reactions, because water is being taken out of these reactions. Okay, mechanistically, if you want to check, then this is what it is. Suppose I've given you an aldehyde, which is R, this, in presence of a weak acid. Okay, this will undergo protonation, forming that, which will be attacked by the lone pair of the amine, RH. Subsequently, there will be a proton loss. Now, this is called carbonyl amine, because there is a OH for which there is a word carbonyl, and for NHR there is an amine, so this is called carbonyl amine. Subsequent protonation, water now acts as a leaving group. So we can think of something like this. NHR, very similar to the mechanism of acetal formation. This is resonance stabilized. From which we can think of loss of a proton. And that is your amine that is formed. Okay. Now they can have the geometrical forms, as I said. Both E and Z are possible. So it can be something like this, and so these are your GIs. It can also be something like that. So keep that in mind. For the amine formation, okay, for the reaction of secondary amine with carbonyl, suppose that is your acetaldehyde or any aldehyde, and I have given you this is your secondary amine, 2-degree amine, again in presence of a weak acid. Here the compound that you are going to get, it is better to give you something like this. the compound that you're going to get is something like this. So this is called a ene. This is your ene part and this is your amine part. So this is called enamine. Now instead of doing the whole mechanism, what shortcut we can use, I will teach you that. But let's go for the mechanism so that you can understand the beauty of the shortcut. So let's do the mechanism first. Now suppose you have a aldehyde, something like this, or say let's take a ketone, something like that. Okay, given you H plus, so obviously protonation will take place. Which will be now attacked by the secondary amine like this. This will lose proton. Say protonation of the OH will take place in the second step, in the next step, not second step. It forms like this. Water is a good leaving group, so water goes away, generating a positive charge on the carbon. Alright, which is again resonance stabilized by the nitrogen. Now next to this double bond, proton is lost from this carbon, leading to the formation of an ene, and that is how you get your enamine. Now instead of going for such a long mechanism to get your answers, just remember my trick, okay? So what I do instead is I will convert this particular ketone to its enol, okay, to its enol. Please note, that is how you make the enol. Now you place the secondary amine next to it and again just take out water. So instead of doing for this long thing, okay, you can easily arrive at the answer by using what I have shown you over here. Okay, so let's do some examples or practice problems. Say problem number 1. One degree amine or 2 degree amine? 2 degree amine. So product will be enamine. That means I have to convert this to a enol and take out water. Okay, and that will be giving me my product. Number 2, I've given you cyclohexanone. Along with that, I've given you piperidine, H plus, again secondary amine, so product will be enamine. Convert the cyclohexanone to an enol, plus the secondary amine in such a way that you can take out water. And that is your product. Okay, so that is how simple it is. Let's do the reaction for a primary amine, say something like that. It's very easy, just take out water and your answer will be something like this. Okay, now